Hi everyone, today we're going to be solving EDEXCEL IGCSE Chemistry 4CHO Paper-1C. Today we're solving June 2017. Guys, in this video we're going to be solving the entire question paper. The diagram represents an atom of an element. We can see the nucleus, we can see electrons on the shells. You may use each number once, more than once or not at all. Atomic number of the atom. So atomic number denotes to the number of proton. We can see the total number of proton here is 3. So 3 will be the answer. The number of shells is the number of number of electron shells they're talking about. So there are 2 of them, so it will be 2. Mass number of the atom. Mass number will be the total number of proton plus neutron. So there is 3 protons and 4 neutrons, so the mass number will be 7. The number of protons in an isotope of this element. Number of protons within an isotope of the element remains the same, right? So it will be 3. Group where the element is found in the periodic table. The element placement in the periodic table depends on the outer shell electron. Since there is only one outer shell electron, so it will belong to group 1. Substance can be classified as elements, compounds, and mixture. Which of these is the formula for a molecule of an element? For example, hydrogen here is just a single atom. H2 is a compound, H2O2 is a compound, so H2 will be the answer. Which of these is a mixture? A mixture means where there is a combination of substances. Sodium is a pure substance, chlorine is a pure substance, sodium chloride is a pure compound. Sodium chloride solution consists of sodium chloride plus water. So this is a mixture. Which method can be used to separate the dyes in a food coloring? In a food coloring, the different pigments are mixed together, so we need to do the process of chromatography. A student adds a large crystal of sodium chloride to some water in a beaker and leaves the beaker for a day. The diagram shows the beaker immediately after adding the crystals and after 1 day. We can see after 1 day, most of the crystal has dissolved. After a day, the student takes the sample from the top of the liquid and tests it to see if it contains chloride ions. The test is positive. Describe how the student should do the test. Include the observation for a positive test in your answer. So to do a test for chloride ions, which means a halide ion, we will need, first of all, we will add dilute nitric acid. This dilute nitric acid is actually added so that we can remove any carbonate ion in the solution which will interfere with the test. Then we are going to add silver nitrate solution, and since the test is positive, so it will give a white precipitate. Silver chloride is white precipitate. Name the process by which chloride ions move from the crystals to the top of the liquid. So at first the chloride ions dissolves and then it diffuses. But dissolving is the process for it to dissolve in the liquid. So we will just talk about the diffusion here. The apparatus is used in a laboratory to separate a mixture of liquids with similar boiling point. Mixture of liquids, water in, water out. So we can see that there is a condenser here. The passage describes what happens when the apparatus is used. Let's complete the passage. The mixture of liquid is placed in the, so it will be placed in the flask definitely. During heating, part of the mixture boils and passes up. Obviously it will pass up the column, all right, and then it will get into the condenser. The water is used to cool the paper in the condenser. So column and then followed by the condenser will be the answer. Which of these changes of state occurs in the separation? So in the separation, we have a gas that we convert into liquid. So guys, an explanation for why A is not a correct answer. It's mainly because within the particular state of changes that we are looking in this particular process, we do not have a solid which is turning into aqueous. So this is not correct. And for liquid to solid, we do not have any changes in this particular process that turns a liquid into a solid. For aqueous to solid also, we do not have anything that is turning from aqueous to solid. We only have a particular substance which is when heated, it turns into a gas, and then we condense it so that it turns into a liquid. So that's why C is the only correct answer. The diagram shows 3 pieces of iron. We can see iron A, iron and zinc, iron that is coated with zinc, and then we have iron that is coated with zinc, but there is a torn part. Name the process used to coat iron with zinc. The process of coating iron with zinc will be called galvanizing or galvanization. The 3 pieces of iron are left in separate drops of water and exposed to the atmosphere for several weeks. The table shows the appearance of the pieces after several weeks. A. Covered in a brown solid. So we can see that it has rusted. B. Shiny and unchanged in appearance. No rusting. C. Shiny and unchanged in appearance. Also we can see there is no rusting. The brown solid contains hydrated iron 3 oxide. What is the common name for brown solid? So guys, it will be rust. identify the two substances that react with iron to form brown solid. So to form the brown solid, there must be water present and there must be oxygen present. Explain the reference with reference to the symbols in the box why the brown solid does not form on C. In C, there is a torn part. There is a part missing for the zinc. Yes. So why it does not rust? The answer will be like this. Zinc is more reactive than iron. So when there is a chemical reaction between water and oxygen, zinc loses 2 electron from Zn2 plus ion, which prevents the iron from losing electron and forming iron 2 plus ion. That's why iron does not react. Instead, the zinc reacts. This is a form of sacrificial protection. The table shows the formula of some positive and negative ions. It also shows the formula of some compounds containing these ions. So we can see Cu2 plus Cl minus. So guys, this particular compound will be CuCl2. You can all guess it. Alright guys. Now they asked us complete the table by writing the missing formula. Okay. So Fe3 plus with CO32 minus will produce Fe2CO3. Alright. So why did we do that? By the way guys, the reason is since Fe is 3 plus, the valency got transferred to CO3, and since CO3 is 2 minus, the valency got transferred to Fe3 plus. That's why we have Fe2CO3 3. And then the last one, ammonium and sulfate. Ammonium is plus 1, so it will be getting the valency of the sulfate, which is minus 2, so NH42SO4. The correct name for the compound with the formula CuSO4, since in this substance the sulfate is SO4 2 minus, so the copper must be Cu2 plus, because they are present is 1:1 ratio. So we will call it copper to sulfate. Which of these description is correct for ammonium chloride solid and ammonium chloride aqueous? We know that ammonium chloride solid, this is white in color, and for ammonium chloride aqueous is colorless. Guys, generally all ammonium salts are colorless. However, if the ammonium salt is with transition element, then the transition element has color. Ammonium salt has nothing. Ammonium has nothing to do in that. Alright. However, if there is a generalized ammonium sulfate, ammonium chloride, ammonium nitrate, all of them will be white in color. These tests are carried out in two separate samples of iron 3 sulfate. Test 1, add sodium hydroxide solution. Test 2, add dilute hydrochloric acid, then add barium chloride solution. Which observation is correct for test 1? So when talking about test 1, alright, we have iron 3 and we added sodium hydroxide. Definitely we are going to get brown precipitate. Alright, iron 3 has a brown solution, and when we will add the sodium hydroxide, it will produce iron 3 precipitate, which is brown precipitate. Okay, the other ones, the green precipitate explanation is actually Fe2 plus. Alright, so the solutions are not correct because after addition of sodium hydroxide, okay, we will get brown precipitate. We will definitely get a precipitate, so solutions are not correct. Now the next one, give the names of the two products formed in test 1. So in test 1, after the addition of sodium hydroxide, we will have iron 3 hydroxide and we will have sodium sulfate solution. Since they asked us for the name, so we're going to write down iron 3 hydroxide and sodium sulfate. In test 2, there is no visible change after adding dilute hydrochloric acid. State why the acid is added. In test 2, whenever we are doing test 2, alright, like dilute hydrochloric acid followed by barium chloride, the main reason we add the hydrochloric acid is to deter any presence of carbonate. We know that sodium carbonates are soluble, and if there are carbonates like those present, those that are soluble, then it will produce a white precipitate with barium ion. So barium carbonate will be formed. To prevent that from happening, hydrochloric acid is used. Our answer should be written to prevent the formation of other precipitate, example from carbonate ions. In test 2, barium sulfate is formed adding barium chloride solution. State the observation that is made. In the presence of sulfate, barium ions give white precipitate. Describe the test to show a sample of copper carbonate contains carbonate ion. The test for carbonate ion is very simple. We will just need to add a dilute acid. For example, hydrochloric acid will do very nicely. So once we add the hydrochloric acid, we are going to see the observation. We are going to see bubbles of gas. Once we will take that gas and we will bubble that gas into lime water, then because the gas is carbon dioxide, the lime water will turn milky. The diagram shows a blast furnace used to extract iron from its ore. So we can see the raw material like coke, iron ore, limestone is put from this particular end, and waste gases are escaping. Hot air is pumped through this end. The molten slag, which is a little bit lighter in density, floats in the top, and molten iron is collected at the bottom, and it is taken from this particular. State the purpose of the reaction in the blast furnace. Carbon plus oxygen producing carbon dioxide. This reaction generates the most amount of heat in the extraction of iron. Carbon plus carbon dioxide producing carbon monoxide. Carbon monoxide is the reducing agent for this particular reduction of iron oxide. So carbon monoxide needs to be produced. Iron ore contains impurity such as silicon dioxide. The purpose of the limestone is to remove this impurity. The word equation for the reaction that occur are reaction 1, calcium carbonate turning into calcium oxide and carbon dioxide. Reaction 2, calcium oxide reacting with silicon dioxide forming calcium silicate. Write a chemical equation for each of these reactions. So for the chemical reaction for 1, the calcium carbonate will be CaCO3 turning into CaO plus CO2. And for the second reaction, the chemical equation will be CaO is reacting with SiO2 to produce CaSiO3, which is calcium silicate or slag. The equation for a reaction that occurs in the blast furnace is Fe2O3 reacting with free carbon producing iron and carbon dioxide. Explain with reference the reactants in this equation why this is a redox reaction. Guys, if we look into this particular reaction, we can see iron oxide is reduced and carbon is oxidized. Why is iron oxide reduced? Because iron oxide loses oxygen and the carbon gains that oxygen given by the iron oxide. Polythene is a common polymer. It is obtained from crude oil by the fractional distillation, cracking, and polymerization. The passage is about the fractional distillation of crude oil. Use words from the box to complete the passage. Crude oil is heated so that vaporization of crude oil can occur. The column has a temperature gradient. The compound in the crude oil pass up the column and dash occurs at different height. So at different height we will have condensation depending on the dash of each fraction, depending on the boiling point of each fraction. The table lists some statement about cracking. Place tick in the boxes to show the 3 correct statements. The molecules that are cracked are hydrocarbons. Correct. We do crack hydrocarbons. Catalytic cracking uses iron as a catalyst. No, catalytic cracking uses aluminium oxide or silica as a catalyst. Cracking is used because of different demand for hydrocarbons. Correct. Since we have more demand for smaller hydrocarbons, that's why cracking is very important. And naturally, we produce larger hydrocarbons more. Cracking reactions are example of addition reaction. No, they are not example for addition reaction. They are rather, decomposition type reaction where we are using a particular process to make a larger molecule into smaller molecule. Cracking produces molecules with shorter chain. That is exactly correct. Let's see the last point. Methane plus oxygen produces carbon dioxide plus water is an equation for the cracking reaction. No combustion takes place within the cracking process. Cracking is done in an inert environment. When one molecule of butane is cracked, there are 3 possible reactions. The equation for these reactions are reaction 1, butane C3H6 and CH4 is produced. Reaction 2, butane C2H6 and C2H4 is produced. Reaction 3, butane reacted to produce a butene plus hydrogen. One product in each of these reactions is an alkene. What is the general formula for the homologous series of alkene? Alkene has a general formula of CnH2n. So it's very simple. What are the names of the products of reaction 1? So products of reaction 1 are, we can see there are 3 carbon containing alkene, which is propane, and we have a 3 carbon containing alkene, which is propene, and 1 carbon containing alkane, which is methane. So we have propene and methane. Draw the displayed formula of the saturated product of reaction 2. The saturated product of reaction 2 is E. So we will draw the displayed formula to do displayed formula. Remember that a saturated carbon carbon contains only carbon-carbon single bond. So you're going to do the CC single bond, followed by all the other bonds are going to be CH bond. So just fill it up until each carbon has 4 covalent bonds. The hydrocarbon formed in reaction 3 has 3 isomers. The displayed formula for one of the isomers is given here. Draw the displayed formula for each of the 2 other isomers. So when it comes about other isomers, alright, we just have to try and make it as simple as possible. There are 4 carbons in this particular compound. So we can draw the 4 carbons and we can put the double bond in between the first and the second carbon. And then we can draw the 4 carbons and we can put the double bond between the second carbon and third carbon. Now, how to fill up the rest of the hydrogens? As I have already told you, count up until 4 bonds. So in this case, because the carbon, this particular carbon had only 3 bonds already, so we just had to do 1 hydrogen. And the last carbon, we're going to do 2 hydrogen. Notice again, guys, there are 3 bonds in here. So we will just do one more bond for this one. For the last one, we're going to do 3 more bonds. The reaction used to make polyethylene can be represented by this equation. We can see there is a CC double bond. Describe the differences between the reactant and product in this reaction. In your answer, you should refer to carbon chain length, type of bond, and states of matter. So 3 things need to be mentioned: chain length, type of bond, and states of matter. So we know that the product that is produced is polyethylene and the monomer is ethene. So let's write it: ethene, polyethylene. So to answer for this, we're going to say the product has longer carbon chain because many ethene molecule makes polyethylene. The word poly literally means many, so it means many ethene. So the product has a longer carbon chain, and the product has CC single bonds. The product has only CC single bonds. Okay, so the type of bond we already understood what type of bond they have. So they have carbon-carbon single bonds. And lastly, the state of matter. Even though ethene is a gas, but the product that is produced, which is polyethylene, so it will be a solid because it's a very large molecule and it has a very high melting point. Guys, this particular answer requires a slight modification because we have to do a comparison between the reactant and the product. So we wrote the product has long carbon chain, the reactant has short carbon chain. And for the other one, the product has only carbon-carbon single bond. We will also have to add the reactant have only carbon-carbon double bond. A student uses the reaction between iron and oxygen in an experiment to find the percentage of volume of oxygen in air. So the diagram shows the apparatus. We can see there is a gas syringe. There is air which is inside a conical flask, alright, and there is iron powder and water. State the advantage of using iron powder rather than the pieces of iron. Using iron powder, the rate of reaction will be faster because of large surface area. Why is it necessary for the student to mix the iron powder with water? The reaction will be very, very slow without the water. The student records the reading on the syringe at the start of the experiment. He then records the reading every day until there is no further change. The diagram shows the syringe at the start and at the end of the reaction. So we can see at the start of the reaction, the reading was 70, and at the end, we can see the reading is around 16. So here 71. Use the readings to complete the table, entering all the values. The student repeats the experiment but obtains a much smaller change in volume. Which of these could be a reason for the smaller change in volume? She uses 10 cm cube of water instead of 5 cm cube. Well, that doesn't affect the rate of the reaction, or that doesn't affect the overall reaction. He leaves the apparatus for a longer time. Then it should give the same reaction. Alright, so that shouldn't be the thing. He leaves the apparatus in a warmer place. It should also give a faster rate of reaction, so that shouldn't be the thing. He uses a smaller mass of iron powder. Yes, this could be the problem, because if the student uses less amount of iron powder, which is not sufficient to react with all of the oxygen, then the volume will be decreased less. During another experiment, the student writes down these values: volume of air in conical flask and glass tube 250, syringe reading at start 90, syringe reading at 20, change of volume by reacting with oxygen is 70. Student correctly calculates the percentage of volume of oxygen in the air. 70 into 100 divided by 90, 78%. Identify the mistake in this working. The error in this particular calculation is that the student has used 90, which is the syringe reading at the start. The student should have divided by the total volume. Use values from the table to correctly calculate the percentage of volume of oxygen in air. So the total volume of the syringe will be, the total volume of the gases will be this 250 plus 90, and the volume of oxygen that decreased is 70. All right, the whole thing then will be multiplied by 100. This will give us 21. Hydrogen iodide can be manufactured from its element using the reaction hydrogen plus iodine producing hydrogen iodide gas. The temperature of 500 degrees Celsius, a pressure of 4 atm, and a platinum catalyst are used in this manufacturing process. We can see the reaction profile if a catalyst is not used. On the diagram, draw the reaction profile when platinum catalyst is used. Catalyst decreases the activation energy barrier. So we will see a decrease in the energy needed in terms of activation energy. Label the diagram to show the enthalpy change and the activation energy for the reaction with the catalyst. So the enthalpy change for the reaction will be this much. So this will be del H. And we already labeled the EACAT, so no need to worry about that. The manufacturer carries out this reaction using the same catalyst at a pressure of 4 atm but temperature of 400 C. State the effect of this change in temperature on the rate of the reaction. The reaction has a del H of -9, meaning the forward reaction is exothermic. The reverse reaction is endothermic. An endothermic reaction is favored by high temperature. So on the rate of reaction, a decrease in temperature means there will be decreased rate of reaction. So the rate decreases. Explain the effect of this change on the yield of hydrogen iodide. At lower temperature, the equilibrium position shifts to the right. So the yield of hydrogen iodide will increase because the forward reaction is exothermic and the backward reaction is endothermic. So if we decrease temperature, that means we are going to get more amount of product and backward reaction will be less favored. The manufacturer then carries out this reaction using the same catalyst of a temperature 500 degrees Celsius but a pressure of 2 atm. Suggest what effect this change in pressure would have on the rate of the reaction. Since we are decreasing pressure will slow down the reaction. That means the rate of the reaction will decreases. Explain the effect of this change on the yield of hydrogen iodide. Since this particular equation, when we look into it, you will see that there are 2 moles of reactant and there are 2 moles of product. So a decrease in pressure will have no effect on the yield of hydrogen iodide because equal number of gas moles and molecules are present on both sides. Bromine, chlorine, and iodine are elements in group 7 of the periodic table. Place ticks in the boxes to show 3 correct statements about the elements in group 7. The elements can be obtained by electrolyzing molten metal halides. Yeah, we can obtain in a group 7 by doing electrolysis of, for example, sodium chloride. Alright, so we have chloride ion, which we can then extract from it, which is correct. The elements with paler colors are lower down the group. No, lower down the group, the element becomes darker in color. Iodine is black in color. For example, bromine is red brown liquid, and then chlorine is a green color gas. You can see the color gets darker as we go towards iodine. The boiling point decreases down the group. Boiling point will increase down the group, so it doesn't decrease. So that will be a wrong statement as well, because iodine is a solid, bromine is a liquid, and then chlorine is a gas. As you can see, at room temperature, the boiling point, we can understand that if it is a solid at room temperature, must have a very high boiling. Elements form covalent compounds with other nonmetals. All right, so that's correct. All right, we know that group 7 elements, they can form covalent compound with other group 7 elements, with other group 6 elements. Their molecules contain 2 atoms. This is also correct. They are diatomic. All of them are gases at room temperature. No, this is not correct. As I have already told you, iodine is a solid, bromine is a liquid at room temperature. Group 7 elements are called halogens because they react with metals to form salt. The word halogen means salt maker. So write a chemical equation to show the formation of potassium iodide. Okay, so potassium will be reacting with iodine. Iodine is diatomic, so it will produce potassium iodide. To balance the diatomic iodine, we will put a 2, and to balance the 2 potassium, we will put a 2 in the left hand side. The equation for the reaction between hydrogen hydrogen and chlorine is hydrogen plus chlorine reacting to produce 2HCl. At room temperature, hydrogen chloride and hydrochloric acid can both be represented by the formula HCl. Insert the state symbol after each formula. So hydrogen chloride is HCl. Definitely is going to be a gas. Alright, and hydrochloric acid, when it is hydrochloric acid, meaning that it has dissolved in water, it means it is going to be aqueous. Hydrogen chloride is dissolved in methylbenzene. When a piece of magnesium metal, magnesium ribbon, is added to the solution, there is no reaction. When water is added to this mixture, it is shaken, a reaction occurs. Explain the observation in this reaction. So first of all, the observation will be, there will be effervescence. Now, why did we see the effervescence? Because once water is added, in water, the hydrogen chloride is able to dissolve and it produces hydrogen ions and form hydrochloric acid. So magnesium metal now has the ability to react with that hydrochloric acid to form hydrogen gas, which is why we see the effervescence. Halogens can take part in displacement reaction with halides. The table gives information about the addition of halogen solution to halide solution. So we can see halogen solutions, bromine, chlorine, and iodine. Alright, when we add it to sodium iodide, we can see a displacement reaction occur. On the other ones, we did not see any displacement reaction. Explain which test gives a result that cannot be used to compare the reactivities of halogen. So guys, in this case, we cannot use the test 2 because in test 2, chlorine does not react with chloride ions. There will never be an observable change. Which observation shows that a displacement reaction occurred in test 1? When we can see the solution becomes darker. In the case for bromine reacting with iodide, we will produce a displacement of bromine. Bromine will displace the iodide and produce, iodine. Iodine will be produced here. All right. So definitely the solution will become darker. Astatine is an element in group 7 that could also be involved in displacement reaction. The ionic half equation for one of these reactions could be chlorine reacting with 2E to produce 2 chloride, and 82 minus turns into 82, gives 2 electron. Write an ionic equation for this displacement reaction. So we can say that chlorine will react with astatide ions, 2 astatide ions, to produce astatine and also to produce 2 chloride at the same time. So this would be the ionic equation. Explain with reference to the appropriate species and to the electrons why this reaction is described as a redox reaction. Chlorine is reduced and astatide is oxidized. How can we tell that? We can see that the chlorine gains electron, the chlorine molecule gains electron, whereas on the other side, astatide molecule loses electron and form astatine molecules. This question is about magnesium and its compound. A student draws this label diagram to show the particles in magnesium metal. We can see delocalized protons. He makes 2 mistakes. State the 2 corrections that he should make in this label diagram. So in this case, we can see that there are no delocalized protons. There will be delocalized electrons. The other one is that this is a piece of metal. So a metal does not have negative ions. So it will be, all of the negative ions will be positive ions as well. So the answer should be written like this. The signs that are negative should be replaced by positive signs, and we need to replace the proton that is labeled by electrons. Explain why magnesium metal is malleable and good conductor of electricity. Magnesium ions, they form layers, which allows them to easily slide over each other. And the delocalized electron, which is in between the layers, they can flow throughout the entire magnesium metal structure when voltage is applied. Thereby, they can conduct electricity. Magnesium is a reactive metal. Its reactivity can be seen in its reaction with oxygen and dilute sulfuric acid. The chemical equation for these reactions are magnesium reacting with oxygen to produce magnesium oxide, magnesium reacting to sulfuric acid to produce magnesium sulfur and hydrogen. In reaction 1, some magnesium is ignited and then placed in a jar of oxygen gas. State 2 observations that would be made. When magnesium burns in oxygen, it produces a bright white flame, and when magnesium oxide is produced, it's going to be appearing as a white solid. Which of these is a correct statement about the gas formed in reaction 2? The gas formed in reaction 2 is a hydrogen. So it makes a squeaky pop with a lighted splint. Correct. It will make a squeaky pop with a lighted splint. It will not relight a glowing splint. That is the test for oxygen. Turns damp litmus paper red. That is the test for any acidic gas like sulfur dioxide. All right. Then it turns lime water milky. That is the test for carbon dioxide. So none of the other ones will be correct. Only A will be correct. The student used this method to obtain a sample of magnesium sulfate crystals. Heat the solution in beaker for several minutes. Dip a glass rod into the hot solution for a few seconds and then remove it. Allow the solution to cool to room temperature. Filter off the crystals and dry them. Why does the student heat the solution? The student's main purpose to heat the solution will be to remove by boiling of some of the water. Explain why the student dips a glass rod into the heated solution. The glass rod is dipped to see when the crystals are forming. The glass rod will indicate the crystallization point when the solution is saturated and crystal starts to appear on the glass rod. Give the formula of the two compounds that pass through the filter paper. The filter paper will easily allow water molecule to pass through. It will also allow any remaining sulfuric acid to pass through, or it will allow the magnesium sulfate to pass through. Now guys, I've given you all of the options, write only two. After drying the crystal, the student weighs them and then heats them until they reach a constant mass. The equation is represented. This is the equation for the heating. MgSO4.xH2O, MgSO4, and the xH2O flies off. The mass of the dry crystal before heating is 17.2 and after heating is 8.3 when they reach a constant mass. We will use this value to find the value of x in the formula of MgSO4.xH2O. To do this particular math, first of all, we are going to calculate the mass of water. So 17.2 grams minus 8.3 will be 8.9 grams of water. Then we are going to calculate the number of moles of magnesium sulfate. First of all, we will divide the 8.3, which is the mass of only MgSO4, we will divide it by 120, which is the MR of MgSO4, and that will give us 0.069 moles. Once we get that, then we will find out the number of moles of H2O. The number of moles of H2O will be 8.9 divided by MR of H2O, which is 18, and the answer is 0.49. And then we will calculate the ratio of MgSO4.H2O, and we will find out that the ratio is 1:7. So X will have a value of 7. This question is about calcium compounds. The diagram shows information about the reaction of some calcium compounds used to make mortar. Mortar contains calcium hydroxide and it's used to join bricks together when building walls. So we can see calcium oxide, which is added to water to produce calcium hydroxide, which is then, in a particular process is turned into calcium carbonate. First of all, to make it calcium hydroxide, we need water. To make it calcium carbonate, we will require carbon dioxide. Calcium carbonate is heated to make calcium oxide, and CO2 just forms as a gas and flies off. This reaction occurs when calcium hydroxide in mortar is obtained from calcium carbonate. Calcium carbonate is strongly heated to produce calcium oxide. Water is added to calcium oxide to form calcium hydroxide. The calcium hydroxide in mortar reacts with carbon dioxide from the atmosphere to form calcium carbonate. Now the calcium oxide reacting with H2O produces calcium hydroxide. Calculate the mass of water needed to react exactly 28 kg of calcium oxide. To do this particular math, first of all, we are going to find the number of moles of calcium oxide. So we will convert the 28 kg into 28,000 gram, and then we will divide with the MR of calcium oxide, which is 56. So we'll divide with 56, the answer is 500 moles. Then we will find out the number of moles of water, which is also equals to 500 moles. Then we will find out the mass of that particular water of 500 moles times 18, which is equals to 9,000 grams, or 9 kilograms of water is needed. Explain why the reaction between carbon dioxide and calcium hydroxide can be described as neutralization reaction. Carbon dioxide is an acidic oxide. So when it reacts with calcium hydroxide, which is an alkali or a base, so that's why it can be referred to as a neutralization. Calcium carbide is a reactive solid. When water is added to it, a gas ethine is formed. A teacher uses this apparatus to investigate the rate of reaction between calcium carbide and water. The teacher uses the method: record the temperature of water in the flask, add a known mass of calcium carbide and replace the bung in the flask. Record the time taken to collect 100 cm³ of gas in the syringe. The teacher repeats the experiment using the same volume of water and the same mass of calcium carbide, but with water at different temperatures. The table shows the result for the 6 different temperatures. So we can see at 21 degrees Celsius, it took 100 seconds to collect 100 cm³, whereas at 60 degrees Celsius, it only takes 10 seconds to collect 100 cm³. Plot the results on the grid and draw a curve of best fit. The teacher plots this graph to show how the rate of reaction varies with temperature. So the rate of reaction with temperature, we can see as the temperature increases, the rate of reaction increases exponentially. Our graph shows that the rate of reaction is not directly proportional to the temperature. There are two reasons why the rate of reaction increases as the temperature increases. One of the reasons is that water molecules move more quickly, collide more quickly, frequently with calcium carbide particles. Explain the other reason for the increase in rate of reaction. So we know that at high temperature, particles have more energy. Since there are more energy, that means there will be more collisions with higher amount of energy than the activation energy. If a particular reaction takes place at a higher energy than the activation energy, then there are more successful collisions per second, which leads to faster rate of reaction. So guys, that's all for this particular question paper. Thank you for watching for this long. Guys, please subscribe to the channel and let the channel grow, and tell your friends about the channel. Question paper like this will be uploaded every day, guys. We have a particular exam specific target. So we are targeting a particular, coming examination for which we will be uploading this particular videos, guys. All right. And, best of luck to your exam. And thank you for watching the video. See you in the next video, guys. Bye-bye.